talk to you a little bit more about lines and what it takes to graph a line. First, I want you to think to yourself, what's the minimum amount of information that you need to graph any line? When I think about this question, I think of two things. The first thing is that I could graph any line if I know 2 points. Or I could graph any line if I know 1 point and the slope. So now let's think about the three forms for lines that we've been looking at. We have slope-intercept form, which you're probably most familiar with because you've seen it often in your prior classes. Then we have point slope form, and we have standard form. What type of information does each of these forms for a line give you? Let's start with slope-intercept form. In slope-intercept, we have b, which is the y-intercept, and we have m, which is the slope. So this form is giving us 1 point and the slope. Our point is 0b, and then we use the slope as rise over run to find a second point, which we can then use to graph our line. So, for example, we might have y equals 3/4 x plus 2. Here we know that our y-intercept, or our point, is 0, 2, and our rise over run is 3/4. We could choose to go up 3, right 4, or we might choose to go down 3, left 4. So let's take a look at that. I'm going to plot the y-intercept, so that should be on the y-axis because it's the y-intercept. Then I'm going to count up 3 and right 4, and I have my second point. I could draw my line between them now, but I just want to illustrate the other part about slope, which is that I could count down 3 and left 4. All three of these points should fall on the same line. Now I want you to remember that this line represents all of the possible values of y and x that make the statement y equals 3/4 x plus 2 true. Ask yourself, how many points are on this line? I've marked 3 points, but there's actually an infinite number of x, y points on this line that make that statement true. Now let's take a look at point slope form. What information are we getting from a line that's given to us in point slope form? We can see we have the slope, which again is our rise over our run, and then we have the point x1, y1. Now, when you're given an equation in point slope form, there's still going to be an x and a y in that equation. And that's there because that makes up all of those infinite number of points on your line that make that a true statement, whatever your equation is. So let's look at an example. We have the equation y minus 5 equals 3/4 times the quantity x minus 4. Again, that x and the y in there represent any pair of points that make this a true statement. So if we want to graph this line, we know our slope is 3/4, that's our rise over our run, and then our point is 4, 5. You're always going to take the opposite of what you see in that equation. If I now go to graph this line, I know a point and I know the slope. So I can plot the point 4, 5, and then I can use my slope. I could go up 3, right 4, or I could go down 3, left 4. Now, do you notice anything special about this line? It's the exact same as the line that we graphed when we were looking at slope-intercept form. It still has that y-intercept of 2, and it has the slope of 3/4. What's the relationship then between the point-slope form and the slope-intercept form? If we wanted, we could take this example that we have and solve it for y. What would solving for y do? I'm going to add the 5 to both sides, and then I'm going to distribute the 3/4. And that's going to give me 3/4 x plus 2. So I've just converted my point-slope form into slope-intercept form. That was a specific example. Let's look at what happens if we do it to the general form. So when I added 5, what I was really doing was adding my y1 to both sides. I distributed my slope, and then because they were actual numbers, I could combine those second two terms. In this case, I can't because they're not like terms. When you have actual numbers there, though, you'll be able to do that. So we have y equals mx, and I'm going to say plus that quantity y1 minus m times x1. So what we're saying here is we still have a slope of m, but now we could think of our y-intercept in this way. So the y-intercept of a line in point slope form would be y1 minus m times x1. You will have to be careful of that, though, because you have to watch out for those negative signs. Now let's take a look at standard form. This one's different because we don't immediately see slope. As you've learned in class, we can take a look at this and find the x and the y-intercepts. So in other words, standard form can give us 2 points that we can use to graph our line. If we want to find the x-intercept, we can plug 0 in for y. And as a separate process, we can find the y-intercept by plugging 0 in for x. Let's take a look at that generally. I'm going to take step 1 on our general form. I have ax plus by equals c. I'm going to plug 0 in for y. Anything times 0 is 0, so I have ax equals c. If I divide both sides by a, I have x equals c over a. Then I'm going to do the second step by plugging 0 in for x. Again, anything times 0 is 0, so I have by equals c. I divide both sides by b, and I get y equals c over b. Because I did this in general form rather than as an example that actually has numbers in it, I've just shown that I can always say that the x-intercept is c over a comma 0, and the y-intercept is 0 comma c over b for a line in standard form. This is called a derivation. We just derived the x and the y-intercept of a line in standard form. You could use this as a shortcut if you wanted from now on, rather than having to go through the steps of plugging in 0 and solving twice. Now let's investigate the relationship between a line in standard form and a line in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. If I want to change this line in standard form to be in slope-intercept form, I need to solve for y. The first thing that I'm going to do is subtract ax from both sides. So I have by equals negative ax plus c. And notice I put the ax first because in slope-intercept form, mx comes first. Now, to get the y by itself, I divide both sides by b. And I'm going to simplify that large fraction by saying this is negative a over b times x plus c over b. So this is telling me that the slope of a line in standard form is negative a over b. And we've confirmed again that the y-intercept of a line in standard form is c over b. So once again, we've done a derivation to show how these two forms are related. If we look at a specific example of this, we could identify each of our letters first. A is 5, B is 3, and C is 7. The first thing I did before was to subtract AX from both sides. So here I have BY equals negative AX plus C. Now I'm going to divide both sides by B and simplify my fraction. So I'm saying my slope is negative 5/3, which again is negative A over B. And my y-intercept is 7/3, which is C over B. That's the relationship between these two forms. In summary, what you've seen is that both standard form and point-slope form can be rewritten so that they look like slope-intercept form.